All right, guys, I'm back again, meaner than ever. Again, we notice the glare here. Hopefully it doesn't cause a big problem, that you can see what I'm doing. I'm ready to post another video now. And I want to continue the conversation I was having before. It's a necessary conversation, and I'll just sort of put some ideas in your head. Listen carefully to what I'm saying. So, when you were in elementary school or 6th grade, they give you some sort of triangle, and they tell you the base is 4, and then they tell you that the height is 6, and then you'd be asked to find the area, and as you're supposed to know anyway, the area is 1/2 base times height, and you said, oh my God, I can do that, 1/2 4 times 6, and without any trouble, most kids can come up with 12 square units. Okay, that's cool, but that's not 8th grade or high school, which is where we're headed anyway. And if I look at another example here that we were doing before, we said, oh, here's another triangle, but they don't give us the height, they just give us the base, and they give us the slant, which turned out to be, as I explained to you so many times, the hypotenuse, and they expect you to know your Pythagorean triples. So when I drop a perpendicular bisector, big word, but it just means I'm splitting this in half and creating a right triangle here, and that half of 6 is 3, so I'll put that little 3 there like that. Then we have a triangle, which is 3, missing something, 5. And we've said so many times before, oh, what's the missing number? Oh, the missing number is what? 4. So then we write with all the confidence in the world that the area is 1/2 4 times 6, and same idea, we get 12. And that would be closer to 8th grade work, but I need to draw your attention to something that turns out to be very important going ahead, and it keeps popping up because we'll be looking for r squared, and we're looking at its perfect squares and whatnot. Let's just imagine the simplest triangle we can in the universe. 1, 1, 1. It's an equilateral triangle. I don't know how smart you guys are, but I can't think of a simpler triangle than that. So why is it that in the Common Core we can't find the area of this? Well, let's take a look at what's going on. I do the same thing again. Since I know the slant, the hypotenuse, I drop the perpendicular bisector, such a big word. I make myself a right triangle, and now I have 1/2 here and 1/2 here. Oh my God, it looks like I know the hypotenuse and I know a leg. So it's a squared plus b squared equals c squared, as we know so well. And then, of course, the c is the hypotenuse, so that's 1 squared. And then one of the legs is 1/2 squared, and that's what we're missing. Okay, does everybody see what I just did here? Well, 1/2 squared is 1/2 times 1/2, that's 1/4. Plus x squared, which is what we're looking for, this missing leg in this case, the height, which equals x. You should keep that in mind. That's the missing leg in this case. And that equals 1, because 1 times 1 is 1. When I take the opposite of 1/4 and move it to the other side and write out my new equation, I get x squared equals 3/4. Oh my God, what is going on around here? When I take square root of, I put the hat over both sides, I get x, because any number squared, I'll restate it again, the square root of any number squared is that number under the hat, as we've said so many times, and the square root of 3, well, 3 is not a perfect square, so that's radical 3, but thank God the square root of 4, which is a perfect square, is 2. And we get this remarkable result. The area of the simplest triangle we can see has the boogeyman included. It's radical 3 over 2, and that turns out to be very important. This number turns out to be very important when you do simple problems in trigonometry. This turns out to be something that we won't be able to avoid. So with that in mind, I'll finish off the other two problems that deal with finding r, but you should realize that at all points in time, the simplest objects that we can think of involve square root of. In other words, radical 3 is an irrational number. And just to make a real quick result of that, radical 3 plus radical 3 equals what? 2 radical 3. Pi plus pi, another irrational number, equals 2 pi. This is where you're going, whether you like it or not. So anyway, having made that point, which I really wanted to make to the class, because we keep on bumping into these things. They keep popping up like a jack-in-the-box, like a boogeyman jack-in-the-box, just popping up. There we go. The area of an equilateral triangle with units of 1, 1, and 1, shockingly turns out to be radical 3 divided by 2. What is that number? I don't know. Radical 3 is around 1.7 divided by 2. So we come up with whatever that is on a calculator, which we're avoiding just for the time being now. But it's certainly, what? Less than 1, because the number on the top is smaller than the number on the bottom. So with that in mind, having said that, having gotten that off my chest, so to speak, I'm going to put a problem up, do it, then do another problem, sort of pause as long as I can, giving time constraints. We're already at 6 minutes and 49 seconds, and I have this cylinder, and I know that the volume is 405 pi. Well, that's so nice to have the pi. You can probably guess what's going to happen to that guy. And the height is 5. Just throw a number out there to make the math easy. So the question is, find r. And again, I'll give you exercises so you can do these for tomorrow. I'll post them over. And I take a look at this and I say, all right, so what do I know? Well, I know that 405 pi, there's the v, equals pi r squared. That's what I'm looking for. Oh my God, there it is, r squared again. Can't avoid it. It's really impossible. Times 5. Okay? So I divide by pi. Goodbye. I divide both sides by 5. And when I do that, 405 divided by 5 happens to be what? 81. Oh, isn't that so nice when we think about that? A nice little perfect square. So I take the hat on one side, take the hat on the other side. As previously explained, you need to know your perfect squares. So 9 equals r. And in this particular problem, if we work backwards, you can do the problem, and you'll end up with 405 pi, obviously in terms of pi. So where am I now? I'm at 8:29. I'm going to be a brave boy and give you one to do and then rapidly do it. And there you'll have your work for tomorrow. There'll be some work to give you kids. Such a horrible thing that's happening to you guys. Here's a question with a cone, and the cone has a volume of 72 pi and a height of 8. And again, we're asked to find r. So I'll pause a second and let you set up the problem. Then I'll do it on the board. We're at 9:04, so we should have enough time. Can't go really anything above 10, otherwise I wasted my time. And we give you a couple seconds here, and then we write in the formula. 72 pi equals 1/3 pi r squared times 6. Well, that's nice that we had that, because we really don't want to deal with the boogeyman, as I said before. So I reduce there to avoid trouble, and now I divide by pi and the 2 over here, and there we see again what a simple problem this is. Where we are again, 36 of course is a perfect square, and there we go that r equals 6. So I can figure everything in here. There's the height, there's the radius, and if I work backwards, I'm going to come up with 72 pi. You can check that out yourself. Okay, so I'm going to stop here. I ran out of juice or whatever they call that stuff.